Don't forget to mute studio. Welcome to Slough and our live coverage of today's Ring of Fire solar eclipse. The event also marks an important milestone for Slough. Today is also our 16th anniversary of our launch, when the first Slough telescopes came online. And since then, we've had thousands of amateur astronomers and space enthusiasts of all interests and expertise levels who have enjoyed using Slough's robotic telescopes to capture millions, and it is millions now, of celestial objects from the live feeds that members watch every night from our flagship observatory at the Institute of Astrophysics of the Canary Islands. More about that a little bit later. So if you haven't already joined Slough, sign up tonight. Great time to do it over the holiday period to join our community around the globe. But for the next couple of hours, we're not gazing through the nighttime telescopes. Instead, we're going to be witnessing the spectacular Ring of Fire solar eclipse. It's called, you may have heard it called, actually, an annular eclipse, which is the real name for it. And we're going to be watching as the moon slowly passes in front of the sun until it's centrally placed, but with a ring of the fiery sun still visible around the pitch black moon. We'll give you a more detailed explanation when I'm joined by our special guest in a few minutes' time. But about our feeds tonight. Now, this is one that's already online. Eclipse hasn't started here at the Hong Kong Observatory. What we're waiting for is about 5 minutes' time, because the moon's shadow hits Earth around the Middle East. But as the sun is rising, so the sun is actually rising in the Middle East for several of our feed partners. So we're going to look at those in more detail, but we've got several feeds set up. We've got the International Astronomical Centre in Abu Dhabi, that's in the United Arab Emirates. We've got the Sharjah, our partner, the Sharjah Academy for Astronomy, Space, Science and Technology. That's where Slough's new observatory is going to be launched next year. And where else have we got? We've got the Science Centre Observatory in Singapore. So that's going to be a fairly cool one as well to see. And of course, we've got the Hong Kong Observatory. So in a moment, we are going to be welcoming Slough astronomer Bob Berman, who runs the Strange Universe Club over at Slough. But before that, in a couple of minutes' time, I want to remind you of a couple of things. If you're a Slough member and you're watching over at slough.com, you'll be able to snap images from the various feeds as they come online. So you can make a cool animation or share your pictures or whatever. So make sure you watch over at slough.com so that you can use the Star Share camera. And if you've got any questions for me or Bob Burn, then you can ask those in our new chat feature on the slough.com website, or you can tweet us to @Slough. And I know the studio in Connecticut are going to be watching our Twitter feed and chat to pass through any messages. And by the way, you can also follow me on Twitter at @AstroPRC. So if you're an amateur astronomer, even a beginning amateur astronomer or an advanced amateur astronomer, then hop over there, because we're going to be doing a lot more with that account and telling you about some of the great new telescopes that are about to come online. I've still got a little bit of a chilly tan from installing the new 17-inch telescope down at our Chile observatory. But anyway, listen, that's all of that. Let's, without further ado, welcome one of the most esteemed astronomy authors, writers, and Slough astronomer extraordinaire, Mr. Bob Berman. Bob, are you there?
I'm here, Paul. Great to be with you as always.
Well, happy holiday seasons to you and actually anybody else out there who's celebrating the holiday season. Not everybody is, of course. What time is it over there for you, Bob? You're on the east coast of the USA, where our studio is. What time is it?
Standard Time. We're heading toward 10 o'clock on this Christmas Day. All the presents have been given out. All the food's been eaten. We're all stuffed and happy. And wow, an eclipse as an extra Christmas present.
It is, and what an extraordinary way to mark the 16th anniversary of Slough's launch. And you've been with us kind of almost from the start, I believe. But listen, Bob, let's do a little back to basics for any of our new viewers who don't really know what's going on with the mechanics of an eclipse. So let's talk before we get into the kind of detail of what an annular ring of fire eclipse is. What's a general solar eclipse? What's it caused by? What are the celestial mechanics going on that cause this?
Well, the nearest celestial body to us, the moon, passes in front of the most important celestial body, the sun. And in one of the great coincidences of nature, both appear the same size. It didn't have to be. The sun is actually 400 times the diameter of the moon, but it's 400 times farther away. So they both appear the same size. And that's critical actually, because today their size is a little different. Normally they appear exactly the same size, which is why the moon can perfectly cover up the sun to give us a total eclipse. But
Okay.
yeah.
So what then makes an annular eclipse? Or why is the moon appearing as a different size tonight to other times when we see a total solar
Well,
eclipse?
because the moon's orbit around us is an ellipse, not a circle. All the planets and all the moons of all the planets are elliptical in orbit. Actually, the closest to circular of all the planets is the orbit of Venus. A circle would be 0.00, and Venus's orbit circularity is 0.007. You and I always remember that because of the 007
Yeah.
connotation. That's and for moons, well, the moons of Jupiter are 0.000. Those go around perfectly circular orbits. That's unusual. Our moon is more normal by having an elliptical orbit, which means that sometimes it's closer, sometimes it's farther. The press has been exploiting that in recent years by talking about a supermoon. By that they
Yep.
mean the times that it's full and is unusually close. Well, unfortunately, well, I shouldn't say unfortunately, that's editorializing about this eclipse. Put it this way, the reason it's not total, the reason we won't have stars coming out in the daytime and seeing prominences splayed along the edge of the sun is because the moon is farther away than its average position in its
Okay.
elliptical orbit. And so it doesn't appear quite as large as it normally does. And so it doesn't quite appear as large as the sun. And so, although where the Slooh telescopes are positioned right now, it will centrally cut across the sun. When it's at maximum coverage, it won't quite be large enough to complete a coverage. So it'll
Okay.
leave behind a circle or annulus, a ring of fire.
Great. And I don't know about you, Bob, but we've often spoken about look at this, Bob. This is the rising sun live coming in from the International Astronomical Centre in Abu Dhabi. This is such a beautiful sight. This is what we were waiting for, and it's happened just exactly on time. So they've been training their telescopes incredibly low to the horizon. That's the foothills in Abu Dhabi. And here we've got the rising sun. So it's around 6 a.m. there for them, and it's already partially eclipsed. So what are we seeing there, Bob? And why does it look so distorted? I've never seen an image like this. It looks like there are two crescents, coming
It
out. But
does
why
look
is it so
distorted.
distorted?
You're right. First of all, having a sunrise uh, right during the eclipse underway is particularly auspicious because what can look stranger, more eerie, more surrealistic, more dreamlike than something that looks like a crescent moon rising, except
Yeah.
it's the sun? But it's not really quite a crescent moon because, as we all know, the normal shape of a crescent moon, it varies from skinny to a little fatter the next night, a little fatter the night after that. We'll see that next week as the moon goes
Mm.
through its lunation. But not this. This is a shape
Ah,
of a crescent sun that does not uh, resemble a duplicate of the crescent moon during a normal month. And that's because different things are happening. We're not seeing the moon in its own shadow, which is what we normally see. We're seeing the sun being blocked by the moon. They both have apparent diameters of the same radius. And so that's what's producing this very odd looking shape. You couldn't be fooled into thinking this was a normal crescent moon shape, except it's the
right.
sun. No, it's weirder than
And,
that. Wouldn't you
and
agree?
We can, and we can see how much of the atmosphere we're peering through at this. The whole thing is kind of rippling and alive. So what we've got here, Bob, is a partial solar eclipse at this point, and we're going to be seeing the moon slowly move across. And this particular feed, the Abu Dhabi feed from the International Astronomical Centre, they are in what's called the path of annularity. Now, we've covered a number of eclipses this year. A lunar eclipse, we know that oh, look at that, they're tuning up that image. This is absolutely fabulous, this feed. What we know is that wherever you could, during a lunar eclipse, wherever you are in the world, if it's nighttime, you can see it happening. But with this annular eclipse, some places are only going to see a partial. So actually, some places will see the sun, but they won't see any eclipse. Other places like Hong Kong are only going to see a partial eclipse, as we're seeing now. But it's only in a very narrow band, this path of annularity, where we're going to see a ring of fire eclipse. So why is that different to a lunar eclipse? Why is it strung along this thin line?
Because now the effect of parallax comes into play. We mentioned earlier that the moon is the closest celestial body to us, and that makes all the difference. It means that if you're on one side of Earth looking toward the moon, well, you're 8,000 miles, that's the diameter of Earth, from somebody on the other side of Earth looking at the moon. And therefore, you're both facing in slightly different directions seeing the moon. We call that a parallax. In other words, there's a different background object, different stars behind the moon from observers on opposite sides of the Earth. Well, right now it's the sun that will be behind the moon, but if you're on one side of Earth, you'll look toward the moon and there will not be a sun behind it. In other words, there'll be no eclipse. If you're on the other side of the Earth, you'll look toward the moon and there will be the sun behind it. Or in between, there'll be various degrees, gradations of the eclipse. So, quite right, only in a particular straight line, narrow band, it's not perfectly straight, it's curvy, could you see the central effect of the moon centrally covering the sun and producing the ring. And that's fortunately where Slooh has stationed all these
Absolutely.
observers and telescopes to bring it to the world.
This is, Bob, we've done a lot of eclipses over the years, over our 16 years, and I think this is actually one of my favorite starts to an eclipse because we're normally there with before the eclipse actually starts, like the Hong Kong feed. So the eclipse has not started there yet. The shadow hasn't reached Hong Kong yet. But to see the rising sun already eclipsed, and the fact that this is actually happening in the Middle East is kind of quite apt with its connections to, crescents. I just think this is one of the best starts to an eclipse that we've ever seen. But we're going to talk a little bit later. I know you've got some strong views, and I have to say I do share them with you. Now, I've had the benefit of witnessing some total solar eclipses. We'll talk a little bit later that you cannot beat a total solar eclipse. They are totally different events to either an annular or partial. But let's now talk generally about solar eclipses and lunar eclipses. Now, how often do these things actually occur? How many do we get on average every year?
On average, there's one total solar eclipse a year, and sometimes there'll be an annular eclipse thrown in, but generally you can expect, on average, one a year, except there'll be a complete skip of 1 year out of every 4 or 5. So once out of every 4 or 5 years, you'll have no total eclipses anywhere in the world. That was actually the
Right.
case just now. We
But
had
yeah,
no total eclipses of the sun in 2019. We will have it in 2020 and 2021. And then we're going to skip one. There'll be none in 2022, but we'll be back in business for 2023, 24, and 25. No, none in 25. So you see,
okay.
it's not quite every year.
Bob, I was just looking at if we can go back to that actually. The feed from our partners, the Dubai Astronomy Group, has just come in, and once again, it's dawn there. The sun has just risen, And I don't know if viewers were able to see that, but there were birds flying across in front of the sun. So, viewers, keep your eyes open, and maybe you can actually snap an image of one of these, but we can see how much it's rippling because, oh, there it was. There's another bird that just whizzed by. We have actually seen um, we were doing another solar show with our partners in Dubai, and we actually had, I don't know if you remember this, Bob, but we had a jetliner fly in front of the sun, and it was the most extraordinary sight. I know you were talking with one of the other hosts at the time, and everybody kind of threw that, and they couldn't.
No,
You all
no.
couldn't kind of
Well,
believe, did I just see something? Was that real? But look, there's another bird that's just whizzed across the screen there. So
well, Paul,
these are
you're famous.
terrific.
You're famous for being easy to please, and
I am.
your excitement and this is so typical of you. Oh, this isn't this the best thing ever,
Another.
and it's wonderful. But yeah, I have to admit it. Yeah, birds flying in front of the sun while the moon is also passing in front of the sun. You know that Native Americans would have something to say about that, but we see it still happening here and there. I wonder what it portends. I recently had that, as you know, you're a pilot yourself, and until
Mm.
recently, you and I both owned airplanes, and I was taxiing a plane at an airport, and a fox ran across my path as I was taxiing the plane for takeoff. And I couldn't help say, well, I wonder what that portends. I wonder what that means in terms of good luck or bad luck for the flight. And you know that the Native American tribes would have had some
Had
opinion on that.
something.
So
Yeah,
I don't know
exactly.
what people would say about
Exactly.
this. We're seeing birds fly in front of the eclipsed sun that's over the Middle East. Also, of course, in the Middle East, the main religion is Islam, and the logo, I know that's not the right word, the symbol
Yeah,
for that
symbol. Yeah.
religion is a crescent moon, which this
Mm.
resembles. So
Yeah.
I'm sure this is very auspicious for them.
And we can see already now that that distortion, that widthwise distortion, because the sun was rising through that thick atmosphere, is lessening now. So things are looking a little bit rounder. But we can already see here, Bob, just the speed at which the moon is passing in front of the sun. Now, this is sometimes I get questions and say, when can I see a new moon? And I tell people, well, actually, not very often. You can't see a new moon every month. This is one of the few opportunities that we ever actually get to see a true new moon because it's
You're so
when
right.
it's usually
You're right.
very
Because
close to the sun.
new moon is synonymous with no moon. At the moment that it's new,
Yeah.
it's in the blinding light of the sun. We're looking at the dark hemisphere of the moon. The moon does not have a permanent dark side, even though Mark Twain
No.
wrote about the permanent dark side of the moon. He knew better. I'm sure he just said that to make a
Yeah.
point. What he wrote was that every man, that's how they spoke back then, every man is like a moon and has a dark side that he doesn't show to anyone.
Ooh. Well,
But
I
he
can.
knew better.
Yeah.
He knew the moon doesn't have a permanent dark side. But look right now. We're seeing the dark side of the moon. It keeps changing what area of the moon is being covered, but we're in a position now to be precisely facing its dark hemisphere, and that's why we cannot see it. That's why it's dark, and normally you cannot see a new moon, but now we'll see it in silhouette in front of the sun.
Now, Bob, I don't know if viewers can spot this. Now, I used to be an architect by profession, and so I'm pretty good at kind of lining things up and seeing geometry and patterns. But I think I can see quite clearly in this stream that the, I can see clearly that the moon is a smaller diameter to the sun. I hope viewers can kind of see that. If you just look at the curvature, it's tighter on the shadow of the moon, and that's what you were talking about. So the moon is further away today by chance at the time of the eclipse, so it appears slightly smaller than the sun. That's why we're not getting the wonderful total solar eclipse. But what is it that um, is there any scientific use of eclipses, either this type of eclipse or a total solar eclipse? And has that kind of changed over history over the last 100 years? What
Yes,
science
it
can be
has
done?
changed. There was a time not too long ago where total solar eclipse not only taught us about the sun's corona, and it still does, that is its atmosphere with its strange super temperature of 4 million degrees. The sun's surface that we're looking at right now, the photosphere, is only 11,000 degrees. That's Fahrenheit. If you prefer Celsius, it's 6,000 Celsius. 11,000 degrees is what we're looking at, but the corona is 4 million. So why? So there's scientific usefulness in studying the corona and prominences that are following the magnetic lines on the sun. Each sunspot is about 5,000 times the intensity of the magnetic field elsewhere on the sun. So we see the plasma, that is broken bits of atoms, that's what plasma is, following, because it's channeled by a magnetic field, and we see those prominences sprout like geysers up from the sun. So you bet there's lots of scientific value in a total solar eclipse, but there is no scientific value in a total lunar eclipse. There is close to no value in a annular solar eclipse like the kind we're seeing now. But nonetheless, now we're talking about aesthetic value, or
Yeah.
just beauty, or how many people will be moved to study astrophysics or astronomy because of the just the sheer beauty of the event today. So we can't say it has no value, right?
Exactly. And one of our feats, I think it's the International Astronomy um, group, they they're using an H alpha telescope, a hydrogen alpha telescope, which filters out a very specific wavelength of light from the sun. And it's very, very similar actually to Slooh's solar telescope. And I kind of introduced in a fairly rushed way at the beginning that Slough has a whole bundle of lovely telescopes that anybody in the world can use. You can watch them all night long. But our main flagship observatory is at the Institute of Astrophysics of the Canary Islands, and that's actually home to some of the largest solar telescopes in the world. But we also introduced, I think 2 years ago now, the Slough Solar Telescope, which comes online during the day, which is great because it's, while we're waiting for the nighttime telescopes to come online, we get the solar telescope. What kind of features, Bob, can we see using a telescope like that? And maybe not talk about solar cycles. We'll maybe talk about solar cycles a little bit later, because there was some interesting news only this week, which maybe we can talk about a little bit later. But what kind of features can we see? Because we will see some of these features, hopefully,
Yes, because
through that telescope,
in the white light that we're seeing the
which
sun,
this is,
yes, which this is and which we normally see, what white means is that all of the colors are mixing together, scrambling together before going into our eyes. Uh, White light, it's like a rainbow in a blender. It's like taking the actual emissions of the sun, red, green, blue, and all the rest, putting them in a blender, scrambling them up, and the human eye's response to it, thanks to the cone-shaped retinal cells that we have, makes us see white. So it's not very useful. It may be pretty, but it doesn't give us much information. So what these Slough telescopes can do using, let's say, H alpha, which you mentioned earlier, is segregate a particular part of the sun's uh, myriad spectral lines and just look at it in the light given off uh, very narrowly. In this case, at 65, 63 angstroms by hydrogen alone, when its electron jumps between the third possible energy down to the second possible energy level, and that gives off not just emissions of that deep red color, but shows us specific detail that takes your breath away, shows you prominences and faculae and sunspot details and granulation on the sun and all sorts of wonderful stuff.
and if Slough members haven't checked this out yet, then hop over to one of the Slough clubs, which is our local star club, I think, which is where members who love to monitor it in the solar telescope and their own telescopes as well, and they share their images, monitor all of this kind of activity. And it's terrific, some of the animations that they've created of prominences, these huge hedgerow prominences coming out from the edge of the sun, changing and morphing, over sometimes minutes, but sometimes the whole day. Some of these animations cover. The Slough Solar Telescope, I think, is one of my favorite telescopes that we've ever introduced and added to the Slooh network. So
Yes,
anybody
and
who is
Paul,
interested in this,
and Paul, forgive me for
mm,
jumping in on you, but
no,
I
please,
can't help notice that just since we started speaking, look how that moon is continuing. It's not pausing. It's
yeah,
continuing to bite into the sun and making that crescent. Now the crescent looks a little bit more like a moon. The is certainly the radius of curvature, as you pointed out, of the black moon that's biting into the sun,
oh yeah,
you can see
this
that
is
it's
great.
a tighter radius of curvature than the sun itself. And you can even get the a glimpse that no, this is not going to be total when it's all done. That black thing that's biting into the sun will not be large enough to cover it completely. But the point is, it's chugging along. The moon moves at 2,287 miles an hour. That's its orbital speed. It's the only celestial object that moves its own width per hour. Easy to memorize. Its own width in space. It's
Yeah,
2,160 miles, if you'll forgive me using the imperial units, miles, not
please
the
do.
metric that the rest of the world is using. But its diameter, 2,160, and its speed, 2,287, almost the same number. So what we're saying is that in 1 hour, it moves its own width. And we're watching that happen right before our eyes right now.
We are. This is a terrific feed. I think we should maybe stick on this one from the International Astronomical Centre in Abu Dhabi. Some of the other feeds might come online as well. Certainly the Singapore Science Centre. Hopefully they've got clear weather. I haven't had time to check with them before we started. But Bob, just going back, we were talking earlier about how many eclipses there are a year, but eclipses also occur, I think, almost without exception, in pairs. So there's an eclipse of one type, and then either 2 weeks before or 2 weeks after, we get another eclipse. What's
Yes.
happening there?
What's happening is that we can only get an eclipse if the moon is precisely aligned with the sun, or if the moon is precisely aligned with Earth's shadow, which is always cast exactly in the direction away from the sun. So we're talking about 3 dimensions. You'll have the sun, the Earth, and the moon. Those are the three players in this act.
Mm,
And they have to be in a straight line in all 3 dimensions. Now, because the moon's orbit, this is the spoiler, the moon's orbit has a little bit of a tilt to the Earth's orbit
okay.
around the sun. It's tilted about 5 degrees. 5 degrees is a lot. It means that most months at new moon, the moon does not slice into the sun. It passes above it. If you were actually watching it in the sky, uh, you would see it passing from right to left if you're in the northern
Mm,
hemisphere, if you're in Europe or the United States or Abu Dhabi for that matter, and you'd see it not crossing the sun but passing below it or above it because of that tilt that the moon's orbit has. So to see an eclipse, you've got to catch it at the places that its tilt crosses the sun. They're called nodes. And there are two nodes, one where the moon goes from below the plane of the sun to above it, and the other where it's passing back again from above it to below it. So if you're right on a node, you get an eclipse. But if you're within a couple of weeks of it, you're close enough to get at least a partial eclipse or some type of eclipse. And that's why, as you correctly said, if there is an eclipse, you're likely to get another type of eclipse. It won't be, if it's a solar eclipse now, then 2 weeks before or after, what you'll get is a type of lunar eclipse. It won't be another solar eclipse. That
So
would
we didn't.
require a whole
So
nother.
we didn't have a lunar eclipse 2 weeks ago. So that means that we've got to look forward in the new year to a lunar eclipse. Then is that right?
That's right, except it's the crummiest of all possible lunar
Yeah,
eclipses.
not
And
a great one.
it's the kind where instead of passing into our shadow, it passes into our outermost shadow. And this particular time, it's passing into the outermost part of our outermost shadow, the penumbral shadow. And when it does that, the full moon does not seem to change. If we announced eclipse tonight, come and join us and see this eclipse. The truth is, and maybe Slooh is doing this, and maybe I'm making an error here by telling people don't bother. But the truth is that moon is going to still look like an uneclipsed full moon during that eclipse because it's a penumbral eclipse and a scanty
And
one at that.
And we've discussed this on numerous occasions, Bob, and I agree with you wholeheartedly when it comes to visual observation of those very shallow lunar eclipses. But when we capture them in images, we do see a very distinct, well, not very distinct, but you can certainly make out a shadow forming over the moon. And in fact, one earlier this year, we even actually saw some colour, even though it wasn't, a total lunar eclipse. But anyway, Bob, you and I have now been talking for 30 minutes. We've got stacks of viewers out there. So welcome everybody. We are going to take a very short break, but when we come back from that break, we are then on the countdown to what is called annularity, when we are going to see the ring of fire. So this is only going to get better and better. So don't go anywhere. If you've got any questions, don't forget you can tweet us to @Slooh, and Bob and I will answer, or do our best to answer any of your questions. So don't go anywhere. We'll be right back. Hello and welcome back to Slooh's live coverage of the Ring of Fire eclipse. Just as a reminder, we've got viewers around the world. Let us know, actually, tweet to us to @Slooh where you're watching from. It's 3:30 a.m. here in the UK. Our studio in Connecticut, and our guest Bob Berman, they must be about 11 o'clock or 10 o'clock, something like that, on the East Coast of America. And we've got feeds from the Middle East. We've got a feed coming up a little bit later from Singapore and another from Hong Kong, all of our partners there. But we can see here, look at this, we are minutes away now from annularity, the actual point where we see the ring of fire eclipse. And I'm also getting loads of messages actually from our uh, our ambassador in India, and they are all up watching the live show because this path of annularity just crosses the southern tip of India. But anyway, I just wanted to tell you very quickly, if you're new to Slough, haven't heard of us before, we've been going since 2003. In fact, today, Christmas Day, was our 16th anniversary. So this is a pretty fitting way, actually, for us to celebrate. I'm keeping an eye on this feed because it is absolutely glorious, isn't it? And Slough operates several observatories around the world, and we're actually opening it early in the new year. Um, and I'm sorry, I'm still looking at this fabulous image. In fact, I'm going to tell you about what Slough does normally in a minute. We're going to get Bob Berman back into the show because we are just moments away now from the annular ring of fire part of this eclipse, and Bob can tell us exactly what we're looking at. Bob, are you there?
Yes, yes. And the most exciting thing right now is you'll notice that the horns, normally we describe the horns as being the points of the crescent moon, but right now the sun has horns. And in a normal eclipse, you won't see this, but right now the horns normally do not extend more than halfway around. But think about it when you've seen a crescent moon. The points of the moon are opposite each other. But look at now how these
There it is, Bob. There it is.
horns are
That's
joined. And
that's
there it
the
is.
start. It's
There's annular.
wonderful. Wonderful. And depending on where you are in the path of annularity, depends on how long this annular phase actually lasts. So we're going to get the total reverse. We're going to get those horns back the other side, aren't we, Bob?
The other side. But now notice the thickness of the sun around the moon. This is a function of how close the moon is. Remember, during a total eclipse, such as the one we're going to have on December 14th of 2020, the moon, that black part, will be the same size as the sun itself, will completely cover it with all sorts of different effects. Now, look at the difference in size, and this really shows you how the moon can vary from us, how it does vary its distance in its elliptical orbit.
It's it's absolutely stunning, isn't it? My OCD is kind of really wanting it to get to its centralmost point so that the ring
We're
is
just about there,
perfectly
aren't we?
concentric.
Well,
We are. I think that's very close.
I'd say the most perfect part of annularity is just about now.
Yeah. It's slightly offset, but that's because they're not on the very center of the path of annularity. They're just slightly further north. The International Astronomical Center, they've moved from their normal location to do this. So they've actually gone to the city of Madinat Zayed. So they're just in this path of what's called the, isn't it the ant umbral shadow that that this that
It's
is
actually
causing
called an
this
anti-umbral shadow at this
anti
point because the umbral shadow landed before it got to Earth, and then it starts expanding again on the other side, and that's where it's being hit. But it's fascinating to think that all you have to do is travel 100 miles on the surface of Earth, and you'll see that black circle of the moon not being central, but being off to one side or the other, which just shows how strong the parallax is, how close the moon is to Earth relative to its size, that just a short travel 100 miles in either direction, and you're not going to get this annularity. You'll see a partial eclipse right now, not an annular
this is
eclipse.
absolutely spectacular. I think actually this is definitely my favorite non-total solar eclipse, if you see what I mean. I mean, we're just waiting, and you know, if we look at this, we're looking at a kind of screen share because we're being fed back this image, but hopefully the quality of this for viewers is such that they may even be able to pick out little undulations in the surface of the moon in that silhouette. So here we go, Bob. This is going to be the end of the annular phase
There
of
we go.
our
Now we
now.
get those horns. If it were a moon, we'd call it the horns of the crescent. Look how rapidly they are going to now spread the other way. And this is a view you just cannot have. You know, some say that the eclipse looks like a crescent moon. Clearly,
Mm,
it does not. This is far
yeah.
weirder.
Yeah.
more esoteric, more like something you've never seen before than any kind of crescent. When have you ever seen a crescent moon looking like this?
Exactly. Now, but
Never.
Bob, we know that well, we respect opinions of most people around the world, but what would this be showing us or illustrating to us for any flat earthers out there, do you think? Is this a good illustration for their cause or not?
Well, it doesn't, unlike an eclipse of the moon, where we're looking at our own shadow and our shadow is round, proving that Earth is round, not only proving Earth is round, but proving it's spherical. No, this doesn't prove that Earth is spherical by itself. Although, as I said, if you traveled even 100 miles in any direction, the fact that it would change, you could then infer things about Earth's shape. No, but what this is showing you is that the moon is obviously spherical. It's round. The sun is round. And so a flat earther would have to argue that even though through our wonderful Slooh telescopes, everything we look at is round, every planet, every moon, and the objects we're looking at today, that Earth alone is not a sphere. So that would be a hard a hard argument to swallow.
And there's something else actually, because the shadow of the moon as it's tracking across, so we saw sunrise when the eclipse was already started, so that was when the moon shadow had hit roughly in Earth's surface roughly in the Middle East. It's racing across now the Indian Ocean, hopping over to the southern tip of India, then going over to Indonesia and then Malaysia and Singapore, and also Hong Kong are going to see a partial phase as well. The speed, Bob, that that shadow races across, and indeed its width, does tell us that the Earth is not flat because it changes speed depending
Absolutely,
on, yeah,
absolutely. But that's something that you have to rely on reports to establish. I'm always aware that the people who believe this flat Earth nonsense think that the government is lying to them about essentially everything, that the astronaut photographs are faked, that any information we give them from NASA or a government agency is fake. And so it becomes, how can you yourself, without trusting anyone, know
mm,
that the Earth actually is a sphere? There are really two ways, two easy ways. One is simply to call up friends who live quite a bit, let's say, to the west of you. For example, if you're listening from America and you're uh, watching this right now and you live on the East Coast or in the Central Time Zone, call up friends in California the next time that you have a sunset and ask their friends where the sun is in their sky. They'll tell you it's about halfway up the western sky. So if you're seeing a sunset, meaning it's on your horizon, but to your friends on the phone, the sun is halfway up the sky, well, then Earth cannot be flat. Just there and then. That it's as simple as that. So there's easy ways for you to find out on your own without trusting anyone.
absolutely. This is a glorious, glorious feed coming in here from the International Astronomical Centre. Now, Bob, in a second, we're going to talk about the solar cycle because there's some interesting news just this week. I mean, the fascinating subject of astronomy is there's always something changing to keep us on our toes. But I have been told actually that the eclipses started at the Science Centre Observatory, which is located in Singapore. So I wonder if we can pull that up, studio. Do let me know if we can't. Um, but while the studio are doing that, then Bob, um, solar cycle. What is it? First of all, um, for an absolute newbie who knows, oh, there it. Oh, look at that. Oh, studio are good, aren't they? Look at this feed here, Bob. Now, this is far further east. So the eclipse there, the sun is actually about 50 or 60 degrees in altitude, so it's really quite high. This is a white light view, so it's giving us the same kind of view that you get through a pair of eclipse glasses, something like that. But there we can see, um, you know, it's it's very different geometry when you're a quarter of the way around the globe. Now, Singapore is also in the path of annularity, so at the end of our coverage today, Bob and I might not be on air for that little section, but we are going to stick with this feed so that you can see annularity in Singapore. But anyway, back to the subject in hand there, Bob. The solar cycle, what is it?
Well, the main solar cycle is the sunspots coming and going. And this was first noticed in 1610 by Galileo and by Scheiner, a Jesuit priest at the time, and the two of them were making careful observations as the years passed, and they saw that the number of spots on the sun changes their frequency, it gets more and more spots, and they also move towards the equator. Never quite reaches the equator, and never, nor do you have spots at the poles, but they change their latitude on the sun and they change how many there are in an 11-year period. Now,
Right.
since we've been able to also measure magnetic polarity on the sun, we found that the magnetic features on the sun also flip their polarity. For example, in the northern half of the sun, from the sun's equator onto the pole, as the sun rotates, and that's a cycle also, the sun spins on its axis, oddly enough, in just about the same time that the moon takes to spin on its axis. That is about a
Right.
month. Sun takes just a little less than a month. As it does so, we see the spots crossing the face of the sun as the sun moves. But the leading spot has a positive charge, and the spot that's behind it as the sun is rotating has a negative charge. But south of the equator, it's the opposite. The
Right.
leading charge has a negative polarity, and the trailing spot is positive. Well, after 11 years, the polarity changes, flips, so that now the spots are reversed. So if you consider the magnetic polarity of the spots, it's a 22-year cycle of sunspot magnetism flips.
And
11-year cycle of sunspot activity, storm activity, and do they affect the Earth? They do. Turns out that the weather on Earth is correlated with the sunspot cycle.
we'll come to the effect that it has on Earth in a second, but in 2017, we installed the Slough Solar Telescope at our flagship observatory at the Institute of Astrophysics of the Canary Islands. So all members get to watch the live views and snap images of that. Now, in 2017, we saw a huge amount of activity still. We saw sunspots, prominences, filaments, these huge, clouds of superheated plasma erupting from the surface. But this year, Bob, things have died down. So this is what was called solar minimum, wasn't it, this year? Or that's what
It
we
sure
believe.
is. We expect that the new cycle, we numbered them, and we just had solar cycle number 24. We're waiting for the first storms on solar cycle number 25, but before they come,
Yeah.
yes, we have a paucity, a scarcity, an absence of solar storms. This year, 2019, there was a time when we went almost 2.5 months
Yeah.
without a single
It
black dot,
was
without a
that
single
was
solar
a
storm. So,
record breaker, wasn't it, that
yeah,
period?
so we're really having a very deep minimum, which is just what we had in the last cycle. We're having a series that's very odd. We The new cycles are coming not when we expect them. The maximum that we were expecting back in 2008 was only half the strength that we expected, and the previous cycle, cycle number 23, was also had a wimpy cycle. So many solar experts are thinking that the sun may be entering an extended period of quiet, of inactivity. And if that's true, that will have an effect on Earth of cooling us. In fact, just at the
Yeah.
time that we're most concerned about climate change in terms of global warming, it could be the sun just by chance is coming to our rescue and may actually produce a period of cooling. If this indeed is true, and we are entering a period of extended solar inactivity.
And there was one of these before, Bob, wasn't there, in history since we've been monitoring the sun, called the Maunder Minimum. Is that correct?
Oh, that was such a scary time, Paul. It started in 1645 and continued until 1715. And during that time, the sunspot cycle, that 11-year cycle, just stopped. There were
Mm.
essentially no spots on the sun, to the point where uh, people studying them, astronomers, could find no sunspots. And they were concluding that those early observers like Scheiner and Galileo, who were claiming there were copious sunspots, we're saying, well, maybe those early people were just imagining things because
Mm,
a big hefty sunspot grouping was so rare that it was the occasion for a scientific paper. You'd write a paper about it. That's how uncommon they were. And just then, during that Maunder Minimum, a whole human lifetime, 70 years of the solar cycle just stopping, as if the sun's pulse had stopped. Well, at the same time, the canals of Venice froze. Nobody had seen that before.
mm.
Icebergs were spotted near the Thames. Fishing colonies in both Greenland and Iceland had to be abandoned. And the colonies in the Americas, this was before the American Revolution, suffered their worst brutal winters that they ever experienced before or since. So yes, it affected us adversely.
So you were talking about, the solar cycle as we've been monitoring it, over the last couple of years, and especially this year, and the possibility that we were entering a very similar period of very, very low solar activity. But I read and saw an image only yesterday or the day before, Bob. It's Boxing Day here, what we call Boxing Day in the UK, which is the day after Christmas Day. It's 4 a.m. here on Boxing Day. I haven't actually been to bed yet since all of the turkey and the wine and everything else, games, been playing games up until about 4 hours ago. But anyway, I digress. I read a couple of days ago um, that the first sunspots of the new solar cycle had been observed.
Oh,
And
good, good, good. I've
and
not been
this is
keeping up on the
and
latest. Well, good. Well, it's been
exactly.
overdue, and it's good to see. We wondered when the first one would have been observed. Well, excellent. That's good news.
And in exactly the same way that you were telling us, explaining to us that we can tell this by the polarity of the sunspots, and sunspots normally appear in these pairs, just like a bar magnet. In fact, there's some terrific photos of a sunspot group that looks like that, and you can see like the iron filings in a physics experiment coming off, forming that. But what they did, they knew that these were not sunspots from the old solar cycle because they had been reversed. So exactly as you were explaining to us. So if this is the magnetic field of the sun flipping, should we expect now solar activity, sunspots, prominences, all of these other wonderful features we see in the Slough Solar Telescope? Would we expect to see those slowly increase, or could we still be looking at a fairly bare sun for
It would be
another 12
fairly
months or so?
fair because remember, it is a 11-year cycle, and
Mm,
we're still at the minimum, so we're at the bottom part. It's like a sine wave. The
mm,
number is still more horizontal than the increase will then slowly increase and then more rapidly increase. Yeah, we're still at a time of minimum, but nonetheless, the effects can still be there. For example, in March, I'm still leading a tour, as I do every year, to
mm,
Central Alaska to see the northern lights, and we see them every year,
lovely.
even during sunspot minimum, because there are always holes in the corona, in the sun's atmosphere, and from these coronal holes, we still get enough activity to inspire the aurora borealis.
And there have been some fairly extraordinary displays. Just I monitor this on several of Slooh's
Oh yes, I hope
partners.
you have to come with us
I would
some.
love to. As you know, Bob, I've only seen one aurora. I live in the southwest of England, so we're a little bit too low to see an aurora from here. But we did an eclipse expedition a few years ago, um, and it was racing across Ireland. The eclipse was visible in Ireland and a few small islands in the North Atlantic Ocean and Norway. And we stopped off at Iceland first because we thought, hey, listen, you never know, we might get lucky and see the aurora. I was absolutely thrilled at that because I'd never seen it before, never visited Iceland either. Very lucky. It's a good job, isn't it? But anyway, uh, we one night we decided to do a show, and we thought maybe we'll get lucky and we might see a little bit of aurora. So I'm with a group of people who, for decades, have been chasing eclipses and indeed chasing auroral dis, um, auroral storms and displays. And what we saw that night, the entire sky from south to north
Yeah.
lit up in huge curtains of
I'm so
purples
glad
and
for you.
reds and greens. And at the end of this live show and at the end of the night, all of these really experienced aurora watchers told me, Paul, don't ever bother to try and see the Northern Lights again because you will never see a display as good as the one tonight. We've been chasing these things for 30 years and we've never seen anything like it. So I'm kind of I'm an eternal optimist as an astronomer, and I think I'll still come with you maybe on one of your Alaska tours to see whether I can bring maybe some of that green Irish luck with me to one of your tours. How about that?
I hope you do. I special interest tours. Yeah,
So
just see if the dates suit you some year. And boy, I'd love to have you. And maybe we can do a Slough broadcast from there as at the
that
same
that
time.
would be that would be terrific. So it may be worthwhile actually talking about this association between the sun and aurora. So you talked about a hole in the sun. Is is somehow that increasing the number of particularly energetic particles that are maybe coming in our direction to Earth? And why can't I see the aurora in the southwest of England, whereas if you go further north, you can? What's the connection here, Bob?
Well, because since these are charged particles coming from the sun, we're talking about mostly electrons, but also protons. They will follow magnetic field lines, and the Earth's magnetic field, as you know, dives downward at the magnetic poles. So that's the spot you want to be around, not the geographic poles of rotation,
Mm,
but the area surrounding the magnetic poles, and not even quite there either. The auroras form a donut, a ring, a glowing ring like a smoke ring that surrounds each of the two magnetic poles. And it just so happens, by good fortune, that the one in the north uh, is almost always over land. It's always over parts of central Alaska. We have our secret favorite spots far
mm.
from any cities and lights, and I think that's why we've been so successful. Unfortunately, for the people in the southern hemisphere, there the auroral oval around for the aurora australis, that is the southern lights, do not pass over any land whatsoever. So it's a tougher job to
Right.
see the southern lights than the northern lights.
Are these highly charged particles, are they dangerous to us? They are protected, we are protected in large part by Earth's magnetosphere. On a planet like Mars, which maybe doesn't have any magnetic field, correct me if I'm wrong, would it be
No,
more
you're right.
dangerous? Would you be pummeled by more high energy
You,
particles, and would that
you'd
be
be
damaging to
pummeled by
health?
that, and you'd also be pummeled by the fact that Mars has essentially no atmosphere. Their atmosphere is only 1/100th of the thickness of ours. In truth, our atmosphere blocks more of the cosmic rays from reaching the surface and harming us than our magnetic field does. So we have a
Right.
double armor of protection against them: our atmosphere's thickness and our magnetic field, our magnetosphere. Mars has neither of them essentially,
Right.
so Mars gets the full problem, and so would unfortunately astronauts en route to Mars. It takes 6 months to get to Mars, and en route you wouldn't be blocked at all. At least on the surface of Mars, the body of Mars is blocking half of the incoming cosmic rays. But when you're in a spacecraft en route, nothing is blocking anything. So it's not exactly a healthful occupation to be an astronaut. Your cancer rate certainly would go up. In fact,
Exactly.
one of the astronauts, Alan Bean, was attributed the leukemia that eventually killed him to very possibly his time above Earth's atmosphere and outside our magnetosphere.
I think some of the space agencies have been running some public competitions as well for ideas about how to shield the occupants of spacecraft on some of these longer missions, to make a round trip to Mars is going to take quite a long time. And there's all sorts of fascinating little devices and designs around to do that. But we're looking now at the Science Centre Observatory's feed in Singapore. We worked with these guys a few years ago on another eclipse, and they're certainly putting on a great show for us here. And we will be seeing annularity here at the end of the show. So if you missed annularity from the United Arab Emirates, then you've still got another chance to see it a little bit later. So, Bob, we're going to take a quick break now. But after we come back, I think we'll hop through the feeds, talk a little bit more about those, maybe talk about what Slough members get up to when they control Slough's nighttime telescopes every night, because I know you're a bit of an expert in that. So viewers, don't go anywhere. Don't forget, if you'd like to ask us any questions, you can tweet us to @Slough, and we'll do our best to answer those questions. The studio will let us know if any of those come in. If you haven't got any questions, then hopefully we're explaining everything correctly. But just let us know where you're watching the show from. So don't go anywhere. The clock here has just hit 4 a.m. as you heard. Don't go anywhere. We'll be right back after this short break. Bye for now. Hello and welcome back to Slooh's live coverage of the Ring of Fire annular solar eclipse, and it just happens to also mark the 16th anniversary of Slooh's launch in 2003. We launched on Christmas Day with our first online telescopes, and we've grown ever since with hundreds of thousands of amateur astronomers and space enthusiasts peering through the telescopes together from around the world. We've got, I was trying to tell you a little bit earlier, if you are interested in this stuff, you should definitely sign up to Slooh, because you'll be able to control these huge telescopes, half-meter telescopes, that's 3-4 feet, something like that. 2.5 feet, sorry. Huge telescopes, 20 inches it is. Huge telescopes at our flagship observatory, which is at the Institute of Astrophysics of the Canary Islands, which is about 300 miles off the west coast of Africa. So they come online, really good timing for people in North and South America. But we also have another observatory in Chile, which opens up the southern hemisphere skies. Now, I have just been on a 3-week trip down there to install a brand new telescope. Once again, a humongous telescope. This one's 17 inches in diameter. It's about 430 mil in new money. And it is going to knock your socks off when you see the live views from this new telescope, and it's going to be launching over the coming weeks. We've also got, we're watching these fabulous feeds, live feeds from the Middle East today. We're actually launching early in 2020 our new observatory in Sharjah, which is one of the Emirates of the United Arab Emirates, and we're going to have 2 huge telescopes over there as well. So we're really looking forward to that, because that's going to help members, certainly on the east coast of the US and also in Western Europe as well, because those telescopes will come on slightly earlier. So it's really easy to use Slooh. You control the telescopes, but what makes Slooh really different is that you can watch what everybody else is controlling the telescope to view. So we always think of it a little bit like a jukebox, that one person is controlling the telescope, but everybody's watching the live views. And our community of members is global. It's absolutely huge. But not only is it huge, but the variety of people's interest. Some are just space enthusiasts. They would watch a TV documentary about space or astronomy, and they love just collecting images maybe from the live telescope feeds. But we've also got advanced amateur astronomers who do art astronomy, which is creating beautiful, beautiful astrophotographs from Slooh's telescopes, all the data that they gather up. We've also got a bunch who love doing a load of science. They track asteroids and comets, and I think they've made nearly 10,000 submissions to the Minor Planet Center because they've been monitoring near-Earth asteroids, these asteroids which pose a potential risk to Earth. So, there's a whole gamut. And it doesn't matter if you're absolutely brand new, or if you own your own telescope, or you're an advanced astronomer. There's a place for you to find your own little corner of our community. So if this is the first time you've found Slooh, then come along, join the community. You will not be disappointed. And don't forget, every day you'll be able to see the fabulous views through Slooh's solar telescope, which is also at the Institute of Astrophysics of the Canary Islands. But anyway, let's get back to today's event, this annular eclipse. Now, the annular phase has already finished in the Middle East, so we're seeing the moon, the black silhouette of the moon, slowly leave the sun. But that shadow is racing across the Indian Ocean, Indonesia, and is going to hit Singapore. Now, if we take a quick look at the Singapore feed, we'll see that there the moon is slowly encroaching on the sun further and further and further. So there we go. As we watch this feed, more and more of the sun is going to be covered. So Bob Bowman, he disappeared on me, but let's welcome back Slooh astronomer. He's an incredible author. He wrote The Sun's Heartbeat. If you're interested in the sun, and if you're watching this, you probably are, read Bob's book called The Sun's Heartbeat. And Bob, you also write for Astronomy magazine and the Old Farmer's Almanac. Is that correct?
Yep. Yeah, quite right. I'm the astronomy editor of the Old Farmer's Almanac. I have been for, boy, more than a quarter
Too
century
many
now.
years.
And I'm a contributing editor and a longtime columnist with Astronomy magazine. I was with Discover for 17 years before that. So all of this stuff is really kind of a monument to inertia.
And a
Uh,
lot of amateur astronomers will know you probably from your column in Astronomy magazine
that's
called
right. Despite the
Strange
fact that
Universe.
that's right. Despite the fact that I'm just making all of this up as I go along.
Never. But you also run the Strange Universe Club at Slough, and we're going to be getting you back to doing your weekly audio shows where you're commentating on whatever members are controlling the telescopes to see, but also if members can listen to you every night because you've recorded some audio descriptions of some of the most popular objects in the Slough 1000 catalogue. So people are listening to your wonderful dulcet tones and your audio descriptions when they're watching the live feeds coming in. Um, through the Slooh's telescope. But anyway, Bob, back to the sun, our subject at hand. And you were talking earlier about um, seeing different layers of the sun. I think you mentioned the photosphere and the chromosphere, and you mentioned, several components and features. What more can you tell us on this subject about our local star?
Oh
Because I
yeah,
think
because
sometimes
it's
we
fast.
forget.
Yes,
Go
because obviously we only see the surface. We don't have X-ray vision. And starting in 1610, we had the benefit of telescopes looking at the surface, so we could see spots and spicules and granulation and faculae, as they're called. We see prominences on the edge during total eclipses, and the uh, beautiful lacy patterns of the solar atmosphere called the corona. But what's causing it, what's underneath. And it's only in
on.
more recent years that we've had new techniques like helioseismology that
Yeah.
measures the pulsations of the sun, because the sun is like a giant subwoofer. Its surface rapidly pulses up and down, and the way it moves tells us about what's underneath, just as the way the earth moves tells us about earthquake, not just formation, but also propagation through the earth. So, through all of this, we've learned. And to me, the most fascinating thing, of course, is where does all that heat and light come from? And that's the
Yeah.
solar core. So, I want
Okay.
everyone to picture that if you could see the sun in the sky, not the place where it's giving off the light. That's what we're looking at. That's this yellow thing. That's the part that radiates all of the light and the heat. It's a very thin layer. It's only about 200 miles thick. So
Wow.
picture it just almost painted on like a shellac. Very, very, very thin layer is letting out the light and the heat. Where it's coming from is a spot in the center. It's only less than a 20th the size of the sun itself, called the core. And in the solar core, listen to this, there's the energy of 96 billion 1 megaton hydrogen bombs
Whoa.
released every second. Every second, there's the power of 96 billion H bombs going off. And all of this unimaginable power radiates and tries to escape, has a hard time doing so because all of the bits of energy and even some solid particles, including particles that don't get stopped by anything called neutrinos, as they're racing out, they encounter more solar stuff because the sun weighs a lot, weighs the same as 333,000 Earths. So it
Ooh.
takes a while before all of that reaches the photosphere, and that's where it actually gets released. So that's the thing that we see. So there's a lot going on under the surface, including apparently a conveyor belt that carries material from the equator poleward and in a kind of circular fashion. And the sunspots we see are just manifestations of that. So a lot is going on.
So, Bob, you talked about some of these particles, and maybe let's think about a photon being generated at the core of the sun. Aren't there some amazing statistics about how long its journey takes to actually reach that thin veneer that you're talking about, 200
Yes, and
miles
you'll
on the
see
surface of
you'll
the.
see different
And
you'll see different figures, Paul.
mm,
Um, a photon itself gets to the photosphere and gets released fairly quickly, but for other bits of material to squirm its way to the surface, you'll read 50,000 years, you'll read 1,000 years, you'll read several months. I found that the literature is so discordant about how long it really takes material to get from the core to the surface that I don't actually trust any of it, which is why I didn't quote anything. So
mm,
it takes, let's put it this way, it probably takes a while because there's a lot there. As I said, the sun weighs the same as 333,000 Earths, or I think to put a figure on it, 10 to the something like to the 33 power grams. So it's a hefty ball we've got there in the center of the
so,
solar system.
so however long this poor little photon takes to reach from the core where it's been generated to the surface is a long time. We don't know specifically how, but it's maybe thousands of years, whatever. But once it's released from the sun's pressure and gravity, it doesn't take long to then reach us, which is
No,
what
that is eight
these
and a half
these are doing
minutes.
now. Eight and a half
Eight and a
minutes.
half
So
minutes
we're
to us.
seeing the sun at the moment as it was 8.5 minutes ago. Is that right?
That's right. And
So it's a little
fortunately, it
bit
doesn't
like a
change
time
that much.
machine.
So we don't have bad seats for the show. It's not like we're so far up in the balcony that we're seeing old news because it doesn't change very much. I should also mention a new layer in the sun between the core and the photosphere that we've recently discovered called the
Hmm,
tachocline. And that's a
okay.
boundary about uh, 7/8 of the way from the sun's core to the edge. And at that boundary, the sun changes from rotating almost like a solid ball, which it does from the core all the way to almost the surface. And then there's the outer 1/7 of the sun or so, where everything is chaotic, where the sun rotates at a much faster speed, takes only about 25 days to rotate. The poles take closer to 30 days. All of this looks like it takes a few days longer because we're going around the sun in the same direction it's rotating. So, from our perspective, it looks like sunspots take not 25 days, but more like 28 to go around the equator, and more like 35 to go around the poles. But that's because we're moving along in the same direction that the sun is spinning. So that gives us a false sense of how long it takes the sun to rotate.
We're so familiar with the sun. It sounds, almost cliche to say that, but this orb in the sky that we see every day, we're fortunate enough to have special telescopes that we can look at it in these wavelengths that we've been talking about. It's quite easy to forget, though, Bob, that the sun is a star, our local star. So how does it measure up in comparison to other stars that we've studied? Is it particularly special? Is it run of the mill? Is it
No,
big,
it's
small?
pretty
What is it?
average. It's pretty average. Most stars are lighter weight than the sun and dimmer than the sun. So the sun is a little bit brighter than average. Only about 13% of the stars in our galaxy are like the sun. We say spectral class G, that indicates a white star. The sun is really pure white. I know some textbooks say that it's yellow. And from the surface of Earth here, look at the photograph. It certainly has a lemony yellow appearance, but in truth, it's a white star. Astronauts and high altitude balloonists, they all report that the sun is as white as snow. So why does it look yellow? It's interesting. This is fascinating. This may be the
Hmm.
most fascinating fact.
Oh,
As the
go on.
sunlight comes off the photosphere, and it consists of all the colors of the rainbow, as it tries to get to us, it has to pass through our air. And the quality of our atmosphere is such, the size of our air's atoms and molecules are such that the shorter wavelengths of light, the blue, get scattered, get bounced in all sorts of different directions, 6 times more readily than the red does. So because of that, we have a sky that looks blue. We get the blue sky, not for free. That blue light had to come from somewhere. So that blue light that gives us the blue sky was robbed, subtracted from the sun's light that was en route to us. So what we see when we look at the sun, like now in this image, or any day that we look up at it, is the sun missing a bunch of its blue light that went into giving us the blue sky. Another way of saying that is that the green and the red part of the spectrum, there's only three primary colors of light: red, blue, and green. So with the blue scattered out, we have an abundance, an overabundance of red and green. And it's a fact that red and green light, when combined, produce yellow. So the sun appears yellow because there's extra red and green coming to our eyes because the blue is missing because it's been taken out to give us our blue sky. So because of that, we have an appearance of a yellow star. But as astronauts tell us, the sun above our atmosphere, the true color of our star, the sun, is really as white as snow. And you can prove that now that it's winter time in the northern hemisphere. The next time you have a snowy day, I'm urging everyone to just look at the snow on a clear day when there are no clouds in the sky, and you'll notice something amazing. The snow is lit up by the sun hitting it, the slightly yellowish sun, but the snow is also being illuminated by the blue sky. So what happens is that those colors recombine. The blue that originally was part of the sun, but now went into giving us our blue sky, bounces off the snow. And the yellowish sun, made of primarily the red and green light, that's all that was left of the sunlight, bounces off the snow. Those two colors recombine to restore the original colors of the sun. And so, what I'm telling you is that the color of snow on a clear day is the true color of the sun that
Oh,
astronauts see.
okay. So I love that fact, Bob. I had some new lenses put in actually to my eyes, and what I noticed there was um, they only do one eye at a time, and my white coffee mug um, through the eye that hadn't been done looked slightly yellow, slightly creamy, but through the new lens was totally white. So I'm sure things kind of change for individuals as well. But I thought suddenly I'm seeing things as nature actually is. My eyes were no longer affecting, kind of putting little filter glasses over. But Bob,
That's
you were
wonderful.
talking.
So in your new eye, you're seeing the blue of the sky, much more richer blue, aren't you?
Everything is a lot richer. So that's rather cool. But Bob, here we are. We're Science Centre Observatory in Singapore. If any of our thousands of viewers that we've got tonight, hi everybody, thank you for joining us. If anybody is ever on a stopover in Singapore, as I was, you need to check out the Singapore Science Centre. It is, and if you've got kids, I mean, I'm just a big kid still, always will be. But if you've got kids, take them along. It's one of the best interactive science centres I have ever visited anywhere in the world. I would say that it's almost worth a diversion if you are anywhere in that region. And Singapore's an absolutely splendid metropolis anyway to visit. But here we go. So we're still seeing in Singapore the moon edging its way towards covering the sun and that annularity. So, Bob, anybody who's joined us a little bit later, could you do a little recap for us about the annular eclipse, what it is, why it's called the Ring of Fire, and why we're not seeing a total eclipse today?
Sure. Because the moon, in its elliptical orbit around Earth, keeps changing its distance. And now its average distance is about 238,000 miles from us. That's center to center, not surface to surface. But because it's not a circle, there are moons around certain planets that have circular orbits. Io, Europa, Ganymede, and even Callisto, the four main big moons of Jupiter, orbit in circular orbits. But most moons have ellipses, and so does ours. So it means the moon gets carried out further away and closer to us. So if it does pass in front of the sun, and you're in a position on Earth where it's going to pass centrally in front of the sun, if the moon happens at that day to be in the nearer half of its orbit, especially in the nearer one third of its orbit, it will appear close enough and therefore large enough to fully cover the sun, and we'll have a total solar eclipse. But if it's in the uh, farther away half of its orbit, it won't appear large enough. It'll just be too far away. And when the moon completely covers the sun, it will appear too small, and it'll leave behind a circle of looks like fire, a ring of fire around it, because it's
Wow.
just not big enough to do the job.
And we've already seen it once from one of our partners in the United Arab Emirates. We're going to see it again in Singapore. We have just, the studio, have just brought this up because this is the partial eclipse that they're going to be witnessing at the Hong Kong Observatory. So the Hong Kong Observatory is working with a bunch of other partners in Hong Kong. I used to work in Hong Kong. That's an amazing city as well. But it's full of amateur astronomers, many of whom are members of Slooh, so they use the Slooh solar telescope and the nighttime telescopes. But these guys are not going to see the annular eclipse that Bob just mentioned because they're not within this thin, it's normally about 70 to 100 miles wide, this thin path of annularity. They're outside of that. So they're only going to see a partial solar eclipse.
And which is pretty
But
amazing by itself. We were talking about that earlier, that all you
yeah,
have to do is go 100 miles or so in one direction or another, and you're no longer lined up correctly to
yeah,
see the moon cover the sun. In other words, the moon is so close to Earth, um, relative to its size, that all you have to do is travel a few hundred miles, and you're off at an angle. And what's behind the moon then is not the sun. You're seeing it from one angle or from another angle, and
mm,
instead you're seeing a different part of the sun behind it, not the full sun, but only a little corner. Look at it right here.
yeah.
You've missed the three-dimensional perfect lineup, and instead you're just seeing a little part of the sun being blocked by the moon. So it's quite amazing that the moon is that close to Earth, that just traveling over the surface of our planet is enough to change the direction towards the moon enough. It's called parallax, so
Mm.
that you no longer get the lineup of the Earth, the moon, and the sun.
Absolutely. Bob, when we come back, we're going to take a short break now, but when we come back, we'll talk about total solar eclipses. And we mentioned earlier on in the show that a total solar eclipse, you told me this very early on when we first did one of our first eclipse shows, and you were trying to explain to me that a total solar eclipse is not like any other type of eclipse, even a 99.99% partial eclipse. And we'll talk about that a little bit later because we've got some opportunities coming up next year and over the coming years for people to see a total solar eclipse. And I know we're both great advocates for people to see this because they really are amazing events. But I think my second favorite after today's event is definitely an annular eclipse. And we've still got that opportunity to see the annular eclipse when it reaches Singapore. We've already seen it in the United Arab Emirates. So anyway, we are going to be right back after this very short break. So don't go anywhere. Come back and we'll give you some good tips about total solar eclipse watching. Bye for now. Hello and welcome back to Slooh's live coverage of the Ring of Fire solar eclipse. It happened on Christmas Day for a lot of you. I know we're on the day after Christmas Day where I am. We've got Slough staff working in on the east coast of the USA, so it's still Christmas Day evening for them. I believe, in fact, yeah, it's 11:30, I think, for them at night. And our special guest, Bob Berman, astronomy author. You've got to read some of his books, and you have to read his articles. His column in Astronomy magazine is set to join us again. Bob, are you there? Now, what do you make of this feed? I mean, the International Astronomical Centre in Abu Dhabi in the United Arab Emirates have given us this absolutely spectacular feed. When we began the show, the sun was just rising above the horizon. What do you make of our live streams tonight? Mm. And these guys, especially for us, they've relocated from their normal observatory, which is in the city of Madinat Zayed, so that they're in the path of annularity. So a huge thanks to them, and the clarity of their image stream has been absolutely spectacular. So we're going to watch this, the end of the partial solar eclipse phase. We've already seen the annular at this location, but we've also got our feed in Singapore at the Science Centre Observatory there. And we're heading in to the annular phase, probably. In fact, if we hop over to that, Bob, you were talking about the motion of the moon and how fast it moves its own diameter. We can probably make a little bit of an assessment here visually if we can get that up, studio, as to how long it's going to be. I reckon it's going to be about half an
Yes,
hour or something like
let's
that.
take a look at that
Hmm.
that image from coming in from Singapore, and it's easy to figure out because the moon again moves its own width per hour. So whenever you see the moon in a position of any sort, just figure it's going to be one moon width moving over in an hour. Now, what direction depends upon where you are on Earth, because our friends
Mm.
in the southern hemisphere are upside down from us. So we see the moon commonly, we being people in Europe and the United States, will see the moon at midday passing from essentially
Oh,
uh,
there we go.
right to left. There we go. Oh, this is good. But in other parts of the world, we see it at different angles in its motion, and that just depends on where you are on the planet.
So, Bob, I would say that's nearly halfway across the sun. Would you say that's about right? So we'd be talking about 35 minutes, something like that, for annularity.
Yes, yes,
Yeah.
yes. I agree with you. Yes.
Okay. So we're going to be on air on this hosted section of the show for another 25 minutes till the top of the hour. But the studio in Connecticut can keep this feed online for you so that you can watch annularity from Singapore. But now Bob and I are going to talk about a few things. We're first of all going to tell you about a total solar eclipse and what makes that so special. Bob, I said before the break, this was one of the first things that you tried to explain to me. I didn't get it when you explained it to me. I couldn't understand why a total solar eclipse could be so much different to a 99.9999% partial solar eclipse. But as soon as I witnessed one for myself, I got it. And as you know, the Slooh team think it's quite amusing because I have not witnessed a total solar eclipse yet, which has not brought a tear to my eye. I find them the most profoundly awe-inspiring event I have ever witnessed. So what can you tell us about the different?
Well, that's the thing. To tell anybody is sort of like trying to tell someone what it's like to fall in love, or to tell someone what it's like to the first time you've swum in tropical waters off Hawaii, when the water is just that perfect temperature. Something that you have to do or see, experience for yourself. And I think it defies logic because, okay, logically, you'd say there's the moon. lined up with the sun in the sky, perfectly covering it. And yes, some stars come out during the day. And yes, you do see the sun's atmosphere. And it's also true that geysers of flame, pink geysers, shoot up from the edge of the sun into space. And it may sound quite lovely, and it is. But the actual experience, somehow, for reasons that I cannot explain, transcend it. And it
Mm.
becomes an event that animals go crazy, people weep. I find that at least half of all people who go to a total solar eclipse are weeping from it,
Mm.
from uh, they're overwhelmed by the experience. And I think if you were blind, you'd know it was happening. There is just
Yeah.
something that happens. You know, I live not too far from Woodstock, so maybe that's why I use terms like the vibe of it. You have to experience the vibe of it, man.
Mm.
But there is just a feeling that comes when the sun and the moon and your spot on Earth form a
Mm.
straight line in space that you have to experience to believe, because it is overwhelming. It
It is. Yeah.
transcends any other, I think, earthly experience. And we've all seen beautiful
Mm.
things. Rainbows are beautiful. The Grand Canyon is beautiful. We mentioned some other celestial sights, an exploding meteor, the aurora borealis. All of these are wondrous sights. But for
So
some reason, nothing can equal a total
mm,
solar eclipse.
no, and it's everything else which is going on around you, as you say. It's one of my favorite segments that we did was on our transcontinental eclipse expedition, and we stopped off um, at a zoo. And I walked around with the keepers, and they had this huge program where they had webcams set up for all of their animal enclosures, and they were asking the public to monitor the animals. And we went live to those cameras during the eclipse, and they were going to, you could see they were disturbed. They started running around the field, and then they got very subdued. And it was the same thing for the humans that were around me. You see this shadow, the moon's shadow, approaching on the horizon, and it's alien. Everything about it is alien and outside of our normal comprehension. And I think that's what I've been trying to understand, what makes it so profoundly astounding to watch. And I just have this feeling that it's everything isn't right. Your brain has not experienced these things, even the things that you're not really noticing, the strange shadows. Your brain is just going haywire. Um, it, and that I'm pretty sure is what makes me overwhelmed when I
That may
witness
be
that. So,
part of it. Also, the unfolding of the event may also do something, Paul, because normally astronomy is like looking at a photograph or a slide. It's unmoving. The Orion
mm,
Nebula, as beautiful as it is, will not look any different 1,000 years from now.
mm,
And the great globular clusters that we see in the wonderful Slooh telescopes they take the breath away, but they will
mm,
look no different in 1 hour and in one lifetime from now. But here you actually see the moon transgressing on the sun's photosphere, and you actually see it covering up that last bit of sun and producing the diamond ring effect. And
mm,
there's actually a grand epic motion of the
there
solar
is.
system. You're seeing the moon in its orbit doing things and producing
Mm,
this spectacle. And it's unlike what astronomy normally is like.
yeah,
It's
yeah.
so without belaboring it, and I've been raving and ranting about this for probably half a century. This is why we urge people to see it for themselves. Yes, of course, we want you
Mm,
to come to Slough and share these eclipses with us, because most of the time you can't be there. You're not going to be able to be in Patagonia probably this December 14th for the next
yeah.
eclipse, and most of our viewers and listeners will not be in Antarctica on December 4th, 2021 for the
Mm,
eclipse after that. So yes, sure, join us here and you'll see many of the phenomena. But if you can go,
yeah.
if you can travel, if you can afford it, the time or the money, uh, please do so. See it at
Yeah.
least once in your life. See a
It's a,
total
it
solar eclipse for yourself.
it should certainly be on everybody's bucket list, and worth spending the money and saving up for it, it's not like you don't know when these things are going to happen. So there's plenty of time to plan. But we're talking about that as being probably the most awe-inspiring celestial event, which I love. We've been very fortunate this year. We saw a transit of Mercury, where we were seeing views like this, but with the tiny planet Mercury transiting across the face of the sun. What are the other kind of spectacles, celestial spectacles that people can see both with their own naked eye out in their backyards, but also using Slooh's big telescopes as well?
Okay, let's do it the way you've segregated it just now.
Hmm.
The spectacles that require no equipment that you can just see with the unaided eye, and the spectacles that are the best that you could see through a
With
good telescope,
telescopes.
like the Slooh's telescope.
Hmm.
Naked eye, we've already established nothing approaches a total solar eclipse,
Hmm.
not a total lunar eclipse. That's not even in the
Hmm.
same ballpark.
Yeah.
Not a partial solar eclipse, nothing else. It has to be all those words and no others. Total solar
So
eclipse. What's
eclipse.
second? Probably a great display of the aurora borealis, the
Yeah.
northern lights, a really fine display like the one you saw, Paul,
Hmm.
that covers much of the sky. A bright one has motion to it. It can light up the ground under your feet. I'd say that's probably number two. Now, number three for a naked eye spectacle, I'd be torn between an exploding meteor, they're called a bolide,
Yeah.
or a very brilliant meteor that casts shadows, that's called a fireball, or a great comet. Once every
Yes.
15 years, on average, we get a great comet. And that adjective is not just it's not a casual, informal way of saying it like, oh, look at that great comet. It's actually the term for a comet bright enough to be seen over cities, even
Hmm.
bulldozing its way through light pollution. And we get a great comet. People may remember Hale-Bopp that we had in the 1990s, and Yakutaki a year from then. There's two great comets in 1996 and 1997. We haven't had one in the Northern Hemisphere since then. But
Hmm.
on average, once every 15 years, we get a great comet. So those are them, a great comet, a brilliant meteor, or a very rich meteor shower. And we don't get those very often,
Hmm.
the northern lights, and a total solar eclipse. Now,
Okay.
as for spectacles that will take the breath away through a good telescope, just judging from all the people that I've watched as an observatory director myself over the years, I'd have to say the greatest spectacles are the planet Saturn with those
Oh, yes.
rings, um, the globular clusters, because they look like a ball containing a million suns, and you actually can see this separate stars that make up this cluster of stars, a million or more stars in a single ball, and there's 150 of those in our galaxy, so there's quite a number of them that look very, very nice through the Slooh telescopes, or a very good backyard telescope if you've got good weather
Hmm.
for it. And those are probably the greatest spectacles, globular clusters of the planet Saturn. And then after that, uh, the Jupiter
Yeah.
doesn't
My
disappoint.
particular favorite.
It's your favorite and my wife's too, by the way. And the moon, you'd think, oh, come on, the moon is so, I know mundane is the wrong word, but you know what I
Hmm.
mean. So common. What aren't you
So familiar.
wasting a really great telescope on the moon? No, because the shadowing changes from hour to hour and night to
Hmm.
night, and there's always amazing craters and details and mountain ranges. It's spectacular. I'm not tired of the moon after watching it
Well,
for.
you've rediscovered it, haven't you, Bob? You were telling me a short while ago that you bought a new telescope, and it's it's reinvigorated your enthusiasm
It
for
has.
lunar observing. Is that right?
Yes, yeah, it's true. I had oh, it's right here. It was a. I don't know if this is going to show up
Yeah, we
at
can see that.
all,
It's a
but
drawing of a crater.
it's a sketch I made at the eyepiece when I was 15 years old of the crater Copernicus, and it just shows that that I love the moon then, and as
Then
you
and
say,
now.
rediscovered it, love it just as much now. You never get tired of it. So yeah,
Yeah.
there's a lot of
But as
amazing
you
things out
say,
there.
the moon, a little bit like the sun in so many ways, is such a familiar object. It's often neglected. by amateur astronomers, and it can be, the curse of a lot of Slooh members who are trying to track down faint and fuzzy objects like galaxies and nebulae and those globular clusters, because the bright moonlight actually adds quite a lot of noise to the images. So this actually at new moon today, in fact, new moon is roughly around now, um,
Yes.
is an absolutely perfect time for a lot of them, and the rest of the time they're absolutely
And since
cursing
you
the moon.
mentioned galaxies and nebulae, with a big
Mm.
enough telescope, and here's where the Slooh telescopes come in, the ability to gather light for several
Mm.
minutes and then process it correctly and even overcome a little bit of light pollution, although the Slooh telescopes are located where there is little or no light pollution. Yes, then you get into the then galaxies themselves, a beautiful spiral galaxy showing those cobalt blue baby stars, and the cores of spiral galaxies often have these campfire yellow cores at the center of them, and the beautiful spiral arms. Yeah, we can't neglect that.
And we've got several members who actually monitor galaxies, and you'll often see them um, setting up their missions, which is controlling the telescopes at Slough. We must keep an eye on this live feed and catch the moment that the moon leaves the face of the sun. But they often set up their missions either very early in the evening or very late at night. And the reason why they do that is that they can observe galaxies which are just setting at dusk or just rising at dawn, where the professional surveys can't point. And these guys, and there's guys and girls doing it, so I use it kind of pejoratively, they are searching for novae and supernovae. What are they, Bob, when we're talking about stars? Because we're looking at our local star now. What's a nova? What's a supernova?
Well, yes, a supernova. Uh, there's two types. The type one happens in a double star system when material from one star, usually a very massive star, uh, accretes on its white dwarf neighbor until enough material falls on the surface to actually ignite and blow up. And a type 2 supernova happens when the star itself, it doesn't need a companion to blow up. In its old age, it just cannot support the weight of its outer layers. So it collapses on itself until the core is impinged on, and then there's a rebound reflective effect, and the whole star produces energy by an entire new method that it didn't during its normal lifespan. So the brightness of a supernova can equal the light of the entire billion, 100 billion
Yeah.
stars of the galaxy that it's from. And so these people are very wise to look for supernovae in other galaxies, because typically one will go off one per century per galaxy. So that's a long wait. But if you're looking at a lot of galaxies, if you're spending each night looking at 100 galaxies, well, now you've upped the odds, and you really might be the first
Yeah.
to find a new
Now
supernova.
we've got members then who have discovered supernova with Slooh's telescopes. They've discovered nova with Slooh's telescopes. They've discovered asteroids. What we're missing, Bob, is one of the discoveries I always think is probably the most important to a lot of amateur astronomers, and that would be a comet. And they're a special discovery because they're about the only discovery you can make which are still named after the discoverer, aren't they?
Yeah, it's the last one. You won't be
So
able to
it's a
find a new galaxy, but if you ever did find a new galaxy, nobody was ever going to call it Bill or Jim. But find a new comet like Borisov, the one that's coming through the solar system now, and it'll bear your name forever. So, yep, that's your last chance for immortality.
So just as we're watching the moon just leaving now the face of the sun in the United Arab Emirates, and this glorious feed that the guys down at the International Astronomical Centre in Abu Dhabi have set up for us today, just as we look at that, you were talking about a supernova in our galaxy, and there is the remnant of one, isn't there, that a lot of Slough members love to capture using Slooh's telescope, Bob. It's Messier 1. What's that one about?
Oh yes, well, the first object on Charles Messier's list, first seen in 1764, excuse me, was originally a star that blew up on the 4th of July in the year 1054. And it was as bright as the planet Venus appears. It was really brilliant, cast shadows, could even be seen in the daytime,
in the day.
and was visible for a whole year. And when telescopes started to be used to look at the sky, starting in 1610, we found that that spot where that brilliant object briefly appeared, or at least it appeared for a year, now is the twisted remnants of, and it's still flying apart. The fireworks are not over. It's still blowing
Mm.
up. In fact, it's still expanding at a rate of 1,000 miles per second. So it's still quite an explosion going on, but it's still just the remnant of the supernova. And so
Mm.
that's, we see it in amazing detail. And the color that it's giving off,
Yeah.
blue, is from synchrotron radiation. In other words, particle accelerators give that off. You may have noticed
Okay.
in movies that nuclear power plants, the liquid that's cooling the fuel rods is always a blue glow. And
Right.
we get that from Cherenkov radiation. This is caused by uh, when particles are going faster than light, and we're seeing that in the Crab Nebula. And we're also seeing synchrotron radiation, which is when electrons have to change their path thanks to the huge magnetic fields there. And when they do, they give off this particular also blue light. So we get a blue light that's not even starlight or campfire light
Mm.
or heat light. We're seeing something that's alien in every sense through the Slooh
Yeah.
telescopes. We're seeing
Yeah.
the blue strangeness, the blue glow of these weird violent processes.
Yeah. Bob, we have seen the end of the partial phase from Abu Dhabi. So for them and for us in this particular feed, the eclipse is over. And just to remind viewers, we saw this as the sun was rising. There was already a partial solar eclipse in this feed from Abu Dhabi as the sun was rising. We then, over about, I think it was no, so only about 35 minutes, 40 minutes into the show, it had reached the annular ring of fire phase. And then for the last 2 hours, we've watched the whole thing uh, deliver these absolutely glorious views that we've had. But let's hop over, studio, to the Singapore feed because they haven't yet had their annular phase. So in this feed, which is further east, that don't forget that shadow of the moon is racing across Earth's surface, and they're going to experience, what do you reckon, Bob? Another 15 minutes, maybe?
Yes, I
Actually,
was going
maybe
to say
slightly
another
longer.
15 minutes, and
Yeah.
the Ring of Fire will be visible there. So I think your intention is to leave Slough viewers with the opportunity to see that, right?
Absolutely. We're going to leave our live broadcast at the top of the hour, but viewers can carry on watching the live feed at slough.com until the annular phase is reached at Singapore. So, but what else can we talk about in these remaining minutes about what we've seen today?
Well, you know, it's hard to put words on the on this grand epic motion of the solar system. It sort of signals to us that despite all the crazy politics and the stuff that all of us uh, you know, have to observe on TV and all the rest, that things are basically right. And there's the universe performing its tick tock regularity, not 1 second too fast or too
Yeah.
slow. And it's happening, the eclipse is happening just as they did thousands of years ago and will happen thousands of years from now. And it's sort of like a sense that, yeah, this is nature, and this is maybe just the correct ointment, the correct soothing remedy for
Mm.
the craziness and the busyness of Earth here down below.
And a rather fitting way for us to celebrate the 16th anniversary of Slough launching on Christmas Day 2003. don't you think? You got involved very early on, didn't you, Bob? 2004, maybe?
Oh yeah, yeah, right from the beginning. I remember going with Mike, our founder, to a meeting in Lower Manhattan, and this is way. And I remember thinking, are they really going to pull that off? Running telescopes from one continent when they're running on another, and being able to broadcast that all around the world. But I shouldn't get into talking about it now, but I knew with Mike's history of success that he had, that I had no doubt that it would be uh, that it would actually be accomplished, and so it has been.
Yeah, and I think what has made that accomplishment is everybody who's involved with it. We're all passionate. You always bring tremendous expertise and your passion and knowledge to the whole thing. We've got a team working on Christmas night in the Slooh studio in Connecticut. We've got Jack and Todd and a few others there. Maybe Ed's there as well. We've got Slooh's operations manager, Andrew Dumbleton. He's actually here in the UK with me. He's running some of the technical aspects of the show behind the scenes. It's about passion, and that passion spills out from the community as well. I think we've got one of the best online communities in the world, Bob. It's so supportive, and we know that this subject is incredibly daunting, but you can come brand new into the Slooh community, and there's always somebody there to give you a helping hand and take that next step. And I know you're a great part of that. You know, viewers do love watching your or listening to your audio shows. So thank you for the part that you've played over the last 15, 16 years. So thank you very much. Bob, we will let you go while I wrap up the show. Thank you so much for joining us on your Christmas Day evening. You're past midnight now. You're just arriving at midnight, are you?
Yes, yes. Well, it's been a pleasure, believe me.
Well, thank you very much, Bob. We'll see you again, I expect, for I think maybe a meteor shower coming up in January. We might see you for that one. So
Okay, thank you.
thank you, Bob. Take care.
Good.
Now, folks, there's always something going on at Slooh. Don't forget, if you're new to Slooh, sign up. It doesn't matter what expertise level you are. If you're a brand new user, never used a telescope in your line, let alone an online telescope, then it is so easy. And if you run into any problems, there's always somebody there to help you. We've also got lots of experts, including Bob Berman. We've also got a chap called Mike Shaw. Now, Mike is an author, an astrophotographer, and he runs our Nightscape Club. So if you just happen to have had a new DSLR camera for Christmas, or you own one, then maybe you can put it to good use and start taking some superb night shots, and you'll be amazed at what Mike has produced with fairly ordinary cameras. So make sure that you check out his weekly audio cast. That's on Tuesdays. And it's just a wealth of knowledge, and you'll open up this whole area of nightscape photography, which is a great way of introducing yourself to taking photos through telescopes and stuff like that. But anyway, we are going to leave you now. I'm going to leave you now, but the live feed is going to continue, so you're going to see the studio will change this tag that's on the screen at the moment, because this is actually from the Singapore Observatory, the Science Centre down there, and they're going to be hitting. It looks to me like maybe a little bit longer away, but we're going to stay on air. That feed's going to stay on air for the next 30 minutes, and you will see annularity if you missed the first annularity that we saw in the United Arab Emirates. Now, you can connect with me on Twitter, AstroPRC, or check out the Slooh community. I run the Astra Club. I'll maybe have a day off tomorrow. Actually, today, that was 5 a.m. The clock was just striking. But hopefully, I'll see you in the Slooh community. It's a great place to be. Hang out. Doesn't matter whether you're an absolute newbie or an advanced amateur astronomer hunting for comets and asteroids. Thank you very much for watching this evening. Thank you very much to all the Slooh crew who are working in the studio and will continue to work in the Slooh studio for the next half an hour. I'm Paul Cox. This has been Slooh and our live coverage of the Ring of Fire solar eclipse. Hope to see you on the next event. Bye for now.